it is a periodic function, then sin kx is equal to, we can write sin kx plus 2n pi. After every 2 pi phase, the position of the wave is at the same phase, then we can write the sin k into x plus 2n pi by k. Here by this lambda is equal to, we can get 2 pi by k. This lambda is equal to 2 pi by k is called a wavelength of the wave. Here in this k is called a wave number. This k is equal to, we can write 2 pi by lambda. This is called a wave number, and this wave number having the units radian per meter, and this wavelength having the units meters, radian per meter. This is the wave number. Now frequency and period. Here for example, this wave is traveling in the medium, then after certain time the wave completes the full rotation. Here period means the time taken to complete one movement. The time taken to complete one movement is called a period. Here for example, if we take a sine, already we have y of 0 comma t is equal to, that is x is equal to 0 I am taking, then a sine minus of omega t will get, where x is equal to 0 and phi is equal to 0 if we take, then y of 0 comma t is equal to a sine minus omega t. This we can get minus of a sine omega t, this minus of a sine omega t. Here this minus of a sine omega t, in that the time period t I am taking, then we can get this, we can write minus of a sine omega t plus omega t. This we can write minus a into sine. Okay, here in this omega t is equal to, we can write 2 pi. That means after every 2 pi phase difference, after every 2 pi phase angular phase difference, then the wave is again completing one rotation, again the wave is repeating. Here for example, if we take this, this is the at this position and at this position, the wave again repeating. From this again the wave is repeating after every 2 pi phase difference. That means if we compare this a minus a sine omega t plus omega t is compared with a sine omega t plus phi, then this omega t is equal to, will get 2 pi. From this t is equal to 2 pi by omega. This is the period. This is the period of the wave. From this we can write omega is equal to 2 pi by t. This is called angular frequency. This is called angular frequency, and the angular frequency having the unit radian per second. Omega is equal to 2 pi by t. This is called angular frequency. And next frequency. Frequency is nothing but frequency. Here this frequency is nothing but the reciprocal of this time period, or nu is equal to 1 by t. This is the frequency of a wave, and the reciprocal of this time period is called frequency, or the number of crest transmitted per second, or the number of waves transmitted per second is called the frequency. Nu is equal to 1 by t, and this having the units hertz or we have cycles per second. These are the units for this normal frequency. Now the speed of a traveling wave. Now if we want to know the speed of a wave, then here I am taking along the positive x direction a wave is traveling, and this wave is traveling at a time t. Now one more wave I am taking, that is here this wave is traveling at a t plus delta t time. Here two waves I am taking. Here one wave is traveling at a time t, and after time t plus delta t, this wave is at this position. Now if we take the displacement from this for this two waves, that is delta x. Here this delta x is the displacement between these two waves. Here if it already we have the equation, that is a sin y is equal to a sin omega t plus omega t, a sin kx minus omega t plus phi. In this, here the wave is traveling with the same phase angle. It is traveling with the same phase and with the same angular frequency omega. Then this kx minus omega t, this kx minus omega t is constant for this wave, because it is traveling with the same phase and traveling with the same angular frequency. Then kx minus omega t is a constant for this waves. Now we can write this kx minus omega t minus of is equal to, we can write k of x plus delta x minus omega of t plus delta t, we can write, because here this is the wave with time t, this is the wave with time t plus delta t, and the displacement is x plus delta x. By this if we solve this, we get delta x is equal to omega into delta t. Here we'll get a kx k into delta x is equal to omega into delta t will get. That is, by this delta x by delta t is equal to omega by k we will get. Already k is equal to we have, that is 2 pi by lambda. If we substitute this value into this equation, then this delta x by delta t is equal to omega by k value. This k value 2 pi by lambda, and this omega is equal to, we have 2 pi by t. If we substitute here, then 2 pi by t into lambda by 2 pi, that is 2 pi cancel, then lambda by t is equal to delta x by delta t. This is called a displacement per time. The change in displacement per time is called velocity of the wave or the speed of the wave. Then the speed of the wave v is equal to lambda by t. This is called a speed of a wave.